Good morning all. Today we are gathered here to conduct the practical on single phase transformer to find the voltage regulation and efficiency of single phase transformer. So this particular instrument is known as single phase transformer. This is the rating of single phase transformer, that is the rating of single phase transformer is 1 kVA. Then it is single phase. After that the primary voltage is 220 volt and the secondary voltage is 110 volt. Then primary ampere is 4.55 ampere and the secondary ampere, that is load current, is 8.7 ampere. Talking about the connection, this is the connection diagram. So you may see here that there is phase and neutral. In between that 230 volt single phase AC supply is supposed to give to the single phase winding, that is primary. After that there is thermostat, or you may say this is single phase auto transformer. It is also probably known as variac. Then so to conduct the practical we have to analyze the reading, the connection. So talking about this is phase. So we have to give from here, we have to supply the phase. So in the diagram, this particular thing, phase and neutral, along with this switch, it is known as ICDP, iron clad double pole. So here iron clad double pole is given. So inside that there is this plunger. If you on that plunger, then automatically this circuit, the dotted line will shows that this circuit will on. After that there is fuse. Then this particular winding is known as single phase auto transformer. So here it is single phase auto transformer starting from 0 to 270 volts. So you may vary from input voltage, here is 240 volts and the output voltage is 270 volts. Then in between that there is voltmeter which is connected. So we have, this is our voltmeter. The range is 0 to 300 volts because we have to measure the single phase voltage, that is 0 to 240 volts. So we have connected the voltmeter here. That voltmeter is primary connection of this. First connection of this voltmeter is at this location and the second connection is connected here. So this is known as the parallel connection. So your voltmeter is connected parallel with the supply. After that, according to the diagram, you have connected your voltmeter. After that, this from the thermostat or single phase auto transformer, it is directly connected to voltmeter M. So from here, from this auto transformer or thermostat, we have connected the circuit, and which is directly connected to point M of this. So this is M terminal, that is main, and here voltmeter consists of 4 terminal which is known as M, that is main, then the L, that is line, then the common and the potential, or you may say this is voltage range. So this M and C we have to connect, we have to short it, so that here with this cable we have shorted the connection. Then from here first we have to connect the connection in series. So this circuit is categorized into two portions. One is primary, this portion is secondary. So from L it is directly connected to ammeter. So from L it is connected to ammeter. So this is ammeter which is of 0 to 5 ampere. So from here L it is directly connected, from L it is directly connected to the ammeter terminal. From ammeter it is connected to the P1. P1 is of, this is 1 kVA transformer connection. We have draw out this connection here. So this is primary connection 220 volts and this is secondary connection 110 volts. So P1 and P2 represent the two terminals of primary side of transformer. So from ammeter it is directly connected to the P1 terminal. From P2 it is directly connected to voltage range of your wattmeter, and from the wattmeter it is directly connected to the thermostat which is mentioned over here. So from auto transformer it is connected to M. M and L are internally shorted. this is known as current coil. From L it is connected to ammeter, from ammeter it is connected to P1, and this is the primary side of your transformer. From P2 it is connected to voltage range, that is 300 volt, because we have to measure the 230 volts. So this is P. We have used common terminal over here, and from here it is connected to thermostat neutral terminal. So this is the connection of primary side. Now talking about secondary side, it is started from the terminal S1. So here it is S1. So initially we have to connect, as because it is secondary side, there is voltmeter which is connected. So we have directly connected the voltmeter. So this particular voltmeter we have directly connect. Here the voltmeter is given. As because secondary side voltage is very less, so we have to use, compared with the primary, we have to use lesser reading, that is half of the reading of primary side. So it is of 150, whereas in case of primary winding it is of 0 to 300. So this voltmeter is directly connected. This voltmeter is directly connected in parallel with S1 terminal and the S2 terminal. Here it is connected. So this is S1 and S2, and the voltmeter is directly connected to these 2 points. This is voltmeter, and these are the 2 points where it is connected. From S1 again it is connected to ammeter. From ammeter it is connected to M, that is main of your wattmeter. Then M and C common. This is the common terminal. After L, this L is known as line. Line is directly connected to the L, or you may say phase terminal of your load. Neutral is connected to the phase, or you may say voltage range of your wattmeter. Voltage range of wattmeter is 150 volt, because we have taken this as 150 volt. So from here it is directly connected to S2. So that secondary side connection is over. I'll again revise it. This is S1. From S1 it is connected to 0 to 10 ampere ammeter. After that M and C needs to short with the small cable. Then this is current coil, and this coil is known as potential coil. Similarly over here, this coil is potential coil, this coil is current coil. Then this is main or M terminal, having rating of 10 ampere and 150 volts. Then this is L. L is line. It is directly connected to load. From the load it is connected to voltage range terminal, that is, you may say this as potential. I use here as a common terminal. From here it is directly connected to S2. So these are the connections of your circuit. Now we have to start the main fuse. So this main switch is on. After that we have to on the thermostat circuit. So thermostat is on. We have to give 240 volts supply. So by looking over here, we have to give 240 volt supply. Now according to the change in variac position, your actual supply is given over here. That supply is, now it is 220 volts. This is 220. We have to maintain this as 220, because the only reason is single phase we have 240 volts available with us, but the problem is in this transformer the primary side rated voltage is 220 volt. That is why we have to give 220 volts over here. Now when we try to take the first reading, then our voltage is 220. So I have to mention here I have to mention it as 220. Now this is 220 volts. Talking about primary current, this is known as no load current. No load current is approximate 0.5 ampere. So here I have to write 0.5 ampere. Talking about wattmeter, this wattmeter is showing very less, so I have to use I'll just assume it as 10 watt. Now talking about 10 watt, it has to come up with the multiplying factor, that is 2. So how the multiplying factor is calculated? We have two methods. Now this particular wattmeter is running with it is having two ratings. One is 300 volts and the 5 ampere. Simultaneously on the secondary side it is 150 volts and the 10 ampere. So in both the side we have multiplying factor available with 2. Formula to calculate multiplying factor is Vi cos phi upon full scale deflection. Now how to calculate full scale deflection? We know about V, that is voltage supplied, then the current which is supposed to measure, and the cos phi, which is available. And cos phi is nothing but the angle between voltage and current. Then talking about the scale, full scale, so this particular thing from 0 to that thing is known as full scale deflection. So it matters that if we are talking about 300 volt, then we have to take this as 1500. If we are supposed to connect it as 600 volt, so it is 3000. Now if we connect this as 150, so it is 750. Now we have to connect here 300, so our full scale deflection is 0 to 150, that is 1500, so it is 1500 for full scale deflection. So the formula becomes Vi cos phi, that is 220 multiplied by 0.5 for this particular reading, 220 multiplied by 0.5 divided by 1500. Now on the secondary side, as we all know, transformer, because primary side there are fluxes which is present, and because of flux present in the transformer, because of mutual action, the secondary side we have the voltage which is induced, known as no load voltage. So that no load voltage is this one. It is showing that it is approximate 108 volts. So I have to write over here V2 is 108 volts. This particular reading is known as V20. Why V20? Because this is no load secondary side voltage. So V2 is secondary side voltage, this is 0 represents no load voltage, and it is 108 volts. Talking about I2, so I2 will give nothing. Reason is, in open circuit connection no current will flow, and that is how we can interpret from here that secondary side there will be no current, so current is 0. That is how we have to write here I2 is 0 ampere. Simultaneously, if we try to mathematically, if we try to multiply this, because V into I is nothing but power, that is W. So V2 into I2 becomes W2. So 108 multiplied by 0 will become 0 ideally, mathematically. Now talking about the actual reading, here it shows 0 on the secondary side. So we are supposed to write here as 0. Now on the second, now talking this particular thing is known as load bank. So this is loading rheostat having number of switches, approximate 10 switches are there. This particular knob is known as on or off knob. Now if I on this, make sure that before on of this particular knob, make sure that all the switches is at off position. If it is at on position, then suddenly the current will rise, on secondary side current will rise, and that is not permissible. So we already take the no load reading. Now talking about load reading, if I on one switch, what will happen? See here on the secondary side, the small voltage drop will be there. Earlier it was 108 volts, now it is 107 volts. Now here some ampere will show, approximate 1 ampere will be there, and here the voltage is given. So secondary side we have current, voltage, that is why we have power. So on the second, now this is for the secondary side. Talking about primary side, first we have to take the voltage. Without differing voltage, when we add the resistive load, simultaneously our voltage will slightly drop down, that is now it is 220 volts. So now it is, earlier it was 220, now it is 219. Ideally speaking, no matter what happen, you have to maintain your voltage. But the problem is, when I try to maintain my voltage, what will happen? If I try to maintain my voltage, if I add the load, simultaneously my primary voltage will be dropped down, and I have to maintain this voltage by using this thermostat. But the problem is, when I try to switch off simultaneously this variac, and by referring this voltmeter, this variac is supposed to move. Many a time we forget to move this, and initial voltage will rise, which is more than 220 volts. That is why we omit this process. So we kept untouched. We are not supposed to touch the variac. Whatever voltage we have, we are blindly supposed to write. So it is approximate 219.5. So it is 219.5 volts. Okay. Now talking about primary current. So earlier it was 0.5. Now the primary current is risen up. So it is 0.7 ampere. Talking about the wattage is also increased. It is approx 60 watt. now it is 60. The secondary side voltage dropped down from 108 to 107. So here I have to write 107 volt. Now this voltage what we have is known as full load voltage. This is no load because no load was on at that condition. Here we are starting the load, so we have to connect it. So this is load voltage. After that, the secondary side voltage we have, the secondary side current, it is approximate 1 ampere. So this is 1 ampere. I have written over here. Secondary side wattage is 60 watt. So this is 60. Simultaneously, if I on the second switch, again there are some changes. So we have to start with the voltage across primary. It is 219 volts. Ideally we have to take number of readings. We have to take reading till one of the condition will match. Rated current of primary or rated current of secondary. How should we calculate the rated current? So rated current will be 1 kVA divided by 220 volts. So what will be the current? The primary current will be 4.5 ampere. Secondary side 1 kVA, that is 1000 volt ampere divided by 110 volts. So my ideal current will approximate 8.9 ampere. So either here on the secondary side 8.9 ampere will become, or here we can measure the 4.5 ampere. So either of the situation if we have, then we have to stop the reading. So now this is the primary side voltage, this is primary side current 1.25. so here it is 1.25 ampere. After that the wattage is approximate 110 watt. Then the secondary side voltage is 106 volts. Then the secondary side current is 2.2 ampere, and secondary side wattage will be 130 watt. Now here I have added these loads. Initially I have added only two loads. So one I have taken 3 readings. One is for no load, another 2 is for load. Now I have switched on the number of switches so that this situation will come. So here it is 4.3 ampere and here it is 8.4 ampere will come on the secondary side and 4.3 ampere is on the primary side. So now at this condition the voltage drop on the primary side because of adding of continuous load is 217.5 volts. After that the current on the primary side is 4.3 ampere. The wattage what we have is 450 watt. Secondary side voltage, talking about secondary side, the secondary side voltage dropped down up to 101 volts. Secondary side, that is V2 load voltage. The secondary side current, or you may say this as load current, is 8.4 ampere, and this one is 480 watt. So this is 480 watt. So this is how we have done with the practical. Number of readings were taken. Now we are going to quickly move to the calculation. Before moving towards calculation, we have started like switch on this one by one. After switch on this we have to take the reading. After switch on this particular switch we have to take the reading. After adding this resistive load we have to take the reading simultaneously. After adding that much load we have to take the reading. So at this load we achieved the maximum load current on the primary as well as secondary side. So our pattern of on the switches are like this: first, second, third, fourth, fifth, sixth, seventh, eighth. Now if you want to off the switches, because we have to off because our readings are over now, so this is the pattern with which we are going to off the load and switch off. After that, before directly switch off here, we have to see, we have to reduce the voltage from here by looking here. So now here this particular knob is at 0, and here we are measuring that the voltage on the primary side is also 0. Now quickly move towards the now. After that we have to switch off this, and before doing anything we have to switch off this one also. Then the next procedure is to go for the calculation. So this is how I have made the table, which has two things: one is regulation and another one is efficiency. Why we calculate regulation and efficiency is, by calculating the regulation we may identify the efficiency of or the efficiency at which your transformer is supposed to run. That is how we have to calculate the regulation. The formula for regulation is V2 I2 cos no load voltage minus full load voltage upon full load voltage. So this is regulation. Percentage regulation is V2NL, that is no load secondary voltage minus full load secondary voltage upon full load secondary voltage. So with the help of this formula we have to calculate the regulation and efficiency. Now try to calculate the voltage regulation with the help of calculator. So here in this case your no load voltage is 108 volt, load voltage is absent, so 108 with respect to this formula, this is 108 minus 0 upon 0. So here the regulation is 0 and the efficiency, first of all we have to calculate the voltage regulation, after that we go for the efficiency. So here the voltage regulation is V2NL. V2NL is 108 volt minus 0 upon 0 will become 0 here. After that secondary, for the secondary second reading it is no load voltage 108 minus 107 upon 107. So here it is 108 minus 107 multiply by 100, okay, divided by 107. So the efficiency the regulation comes out to be 0.934. So here I have to write 0.934. So this is percentage. So here we have to write it is in percentage. So 0.93%, or you may add this in per unit also. So you have, instead of multiplying 100, if you not multiplying 100, so it is in per unit. If you multiply 100, so it is the percentage. After that, talking about this reading, so it is 108 minus 101 upon 101, that is V2NL minus V2 upon V2. So in this case 108 minus 101 multiply by 100 divided by 101 will become 6.93. So here fourth reading is 6.93 percentage. Ideal reading, ideal regulation has to be 2 to 5%. If your voltage regulation lies in between this range, so we may assume that the efficiency of this particular transformer is as high as possible. Ideal thing with this range, ideal range is 3 to 3.5. Now talking about the efficiency, so efficiency is W2 upon W1, that is output upon input. So efficiency is equal to W2 upon W1 multiplied by 100 if I'm talking about percentage efficiency. So here it is 0 upon anything will become 0, so here efficiency is also 0%. Talking about here 60 into 2, 60 into 2, your efficiency is 1. here it is 130 into 2 and 100 into 2, so it is 130 divided by 110 will become now. Talking about the last reading, it is 450 and 430, so 430 divided by 450, it will become 0.95, or you may say this as 95%. So this is the efficiency what we have after calculation. Few alterations may be there, like it may possible that because of faulty reading you may land up with the your efficiency may come out to be more than 100, but practically this is not possible, because if you try to calculate the efficiency, actual efficiency, then this particular formula, that is W2 upon W1, if you want to express this, so it will become percentage efficiency is equal to V2 I2 cos of phi 2, that is load or the secondary side. V2 is the secondary side voltage measured, then the secondary side current measured, and the cos phi 2 divided by V2 I2 cos of phi 2, that is the output upon output plus loss. So here there are fixed loss or plus variable loss. So because of these two parameters known as fixed loss and variable loss, remember that your input, so this formula is nothing but efficiency is equal to output upon input, or you may replace this input is equal to output plus losses. So with the help of this input, if we replace this with output upon output plus loss, so losses can be categorized as fixed loss and variable loss. So here this is variable loss. The variable loss can be, so formula will now become V2 I2 cos phi 2 upon V2 I2 cos phi 2 plus fixed loss plus variable loss.